In the software industry, we always work for the stated requirement, and there are certain requirements which are unstated, which impacts the performance of our system. Let us understand these things. So always there are two type of requirement. One is that stated requirement. This comes either from the product manager or it comes from the market, and also sometimes it has been given by the user experience or testing experience that what is functionality of system. But in some cases there are unstated requirement which we don't work, or we forget to work on those unstated requirement. I'll give you some examples. Like when we do the login requirement is always comes that it has username and password. But there are certain unstated requirement of security. For example, it should be minimum 12 characters, or it should have a complex password, or it should have a multi-factor authentication. These unstated requirements are called non-functional requirement. Nowadays, some of the requirements which are unstated are also part of our functional requirement. But still, there are few requirements like performance, scalability, or all the abilities which we have into the system, like availability, scalability, its usability. All these are unstated requirement. On this, scalability is one of the major one. Let us see that how these has been divided into a different ways of that unstated requirement. So all the abilities are generally a unstated requirement like performance, operating, interfaces and economics. Performance is the system performance, that how you can scale up, how you can make it better, how these things are going to help in running my system. Operating, that where we are going to put, whether it is a Windows or different servers. Interfaces is going to be how we are going to interact with the system. Economic is that how it is going to be a cost. These are called the NFR in software engineering, that is non-functional requirement in software engineering. Now we are going to discuss some of them. The abilities which are coming out of the performance are majorly scalability. Scalability could be horizontal or vertical scalability. Availability, that how much system is going to available. It is going to be a 3949 or 59. 39 means 99.9% available, 99.99% available, or 99.999% availability. Similarly, the interoperability is another things where both environment and performance are playing a role. Security is one of the performance ability, that once you have that secure system, performance always goes down. So security always comes with a hit of performance. For example, if we are using the protocol normal HTTPS, it is a faster protocol versus HTTPS. So HTTP and HTTPS are having some differences on the performance. So as soon as you go onto the encryption always reduces the performance of system, but it has a high security. So security is one of the aspect of performance. Then response time of the system, how quickly it is responding on any of the requests. Next is that reliability, how your system is reliable when more request is coming and you are able to do the same performance. In order to handle these things, we need to understand that what are the design patterns. So what is exactly the design pattern and why we need? Design patterns is basically a language which is a collection of patterns where we have the two goals. One, that it enables that you decide whether it is something is good for your application, or something enables that how you can architect the entire system in your piece of work. There are certain design principles of microservices. Whenever we define any microservice era, it has a design for self-healing, where in distributed system, if anything happens, your system should self-heals and it should work onto the failure. Make all the things redundant. So whatever you are keeping onto the application, it should have redundancy. Anything should not have a single point of failure. It should have the minimize onto the coordinations between different applications for scalability. It should be scale out design where you can have this vertically and horizontally scaling. Kubernetes is one example that you can scale out the different pods horizontally, whereas you can scale out onto the VMs and you can add the cores vertically at any point of time. Then partitions around the limit. So on your network, database, compute, anything, you can partition, slice entire network or entire compute to a smallest unit. For example, if pod of user service which is a less utilized, you can limit that compute to a zero point 0.1 core, whereas transaction information which is a higher, you can go up to a 2 cores, 3 cores. So you can limit, whereas user service is going to use very minimal resources. Similarly, you can have the designs for operations. So whenever you design these services, it should be good and operations should have all the tools they need to work it out. For example, if you have the system, you should have the EFK as a centralized log monitoring, alerting mechanism using the Kibana, Prometheus or Grafana, and it will help your operating team to manage your system well. Then use best of the data store, that whatever the data storage you are picking, it should be properly configured, it should fit for your data. Also, this should not over or under. If it is overutilized, it is going to be a problem. If it is underutilized, it is also going to have a problem. If it is optimum, then that is a best design. Then also the design should always have its own path for evolution, that if you have any application, tomorrow if something is going to change, you are going to do all those changes in a evolution phase. It should not be that one of the module which is a bigger module, and if you have to rewrite that, it takes months or years to complete. So if you have a smaller services, you can take that design obsolete within matter of days, not the weeks. Then it is a design for evolutions. Also, it should always have a build onto the business need. If some business decision needs certain changes onto requirement, you have to take out one or two services offline and do the changes rather than working onto the whole entire system. Based on these design principles, the major four areas which require to work onto the performance. The first is your database. Second is your application, be it a Java application or Golang or any application. Third is that operating system. Fourth is a network queuing and your streaming informations. So I'm going to discuss all those things in my subsequent videos, where we will have in hand practical work, that how each and everything is going to affect on my performance. I am not going to give a only theoretical lecture over here. I am going to provide all those informations practically and show you the differences in different aspects, that how it is impacting the performance. If we have system A with X configurations, system B with Y configurations, and if you run the applications, how it is going to change, either if you change onto the database, if you change onto certain modifications onto applications, or certain modifications onto the different streaming, queuing, networking. So how it is going to impact, and best fitted things can be applied in your application whenever it is needed. So be ready with me. Keep learning and better performing. Thank you for watching this.